streaming. And then I'm looking for the PDF because that's what we'll be talking about today. So OBS is on, so that means I can stream from Discord, share the screen at least. So OBS is right here.
Nice new background, Tuck.
Oh, thank you. It's you can make it very easily using the GIMP. The GIMP has some scripts, and some of the scripts would just generate these psychedelic type of patterns. All right, so I think live streaming is on. Okay, yep, it is live. And I just need to get my PDF back up. Yep, there we go. Yeah, I have a 4K monitor, but I somehow managed to not only use up every single pixel of that screen, and then I have like 20 tabs, on each browser too.
All right. Looks like it's time for you to get the G9 from Samsung back.
The G9, what is that?
It's the first 4K ultra wide. It's like 10-bit and has like an insane refresh rate. Everyone's been like raving about it. Who likes ultra wides?
How big is it? I mean, physically.
50 inches wide.
Oh, 50. Oh, okay.
Yeah, it's extremely big. It's just ridiculously huge.
That actually might be helpful. So when I talk, my spit won't land on the screen, then I have to clean it up. But now I have my my half mirror, actually intercepting my spit, so I have to clean that up, a little bit more often than the actual screen itself. All right, so it is 11:01, so I am going to rejoin the class. This is, they call this high flex teaching, where it is you basically blend synchronous and asynchronous kind of teaching. They just give it a fancy name. I just do whatever I need to in order to get things to work. All right. So I'm not reading any questions about questions 1 to 3. So I am hoping that people who are joining us, now in the live session, have actually read or have actually looked at the previous exam and already watched my video for the first half hour. So I'm basically looking at no questions, which implies that people have watched it and understood the entire thing. So can I make that assumption? Okay, here's Omar typing. All right. First 3 are easy, okay. All right, so after I get all the feedback about the first 3, we can move on to number 4 and number 5. So I'm just gonna scroll to number 4 unless people have questions about number 5. So Aaron is good and Sandeep is typing. So I'm just gonna wait a little bit. Oh, by the way, about adding to the class, the dean has told me we only got 2 people that I needed to add to the class. So the dean told me that that is still being worked on. Admission and enrollment. That particular office on campus is overwhelmed. So so that means that it might take them a little bit longer. But the dean said she would keep me up to date about any development over there. But apparently they are taking on the responsibility to add people. They're not answering their phones. Yeah, so that's not a very good sign, because either they're running, they have too much to do, not having enough people, or something else is going on. Oh, really? Okay, that's interesting, because FLC is one of our smallest campuses and ARC is one of the largest, we're the largest campus. Even compared to Sac City, we are still bigger by a margin. FLC is like I think 1/8 of our enrollment, maybe 1/6 to 1/8 of our enrollment. So they're actually really, really small compared to us. But that's also partially maybe why they have, extra hand on deck, because, they don't have as many people. Yep, exactly. All right, so what we'll do is we are moving on to question number 4. So question number 4, is, okay, I'm just going to read out the question and then we'll go ahead and answer it. Function g, which refers to the aleph null module, the space folding function. In some scenarios, multiplication and division operations are best avoided to limit processing abilities. Due to limited processing abilities. So this particular statement, let me just kind of highlight it here, because I want people to understand the context of this question, okay, because that really helps to understand what I'm expecting people to answer. So on certain architectures, there's no hardware multiplication or hardware division. So they will all be done using software. So you basically end up with loops, okay? As efficient as they may be, okay, in software, they're nothing compared to hardware multipliers and hardware dividers. So as a result, we want to be able to calculate, the g function, but hopefully without using multiplication. So let me just continue to read. Assume that in one situation, only the natural number corresponding to coordinates along the lower left to upper right diagonal line is needed. Now this part is not easily understood in this class because the way I displayed the numbers, the two-dimensional space, is actually flipped, on the y-axis. So when I refer to lower left, that would be coordinate 0, 0. And then upper right would be the pixels where the x and the y values are the same. Okay, so this particular diagonal line is would be the diagonal line where x, y are the same in the coordinates. So 0, 0, 1, 1, 2, 2, 3, 3, those are the pixels on this particular diagonal line. In this class, I will have to make this statement more clear because of the way that I talked about it in this class. But the following sentence clears it up, right? In other words, the program only needs to compute g of kk for some k as an element of n. Furthermore, assume that the program keeps track of j, which is a particular variable, which is defined to be g of kk, and we can use such a value j to compute g of k plus 1, k plus 1. In other words, by the time we need to compute the g value of k plus 1, k plus 1, we already have the value of g of kk. Okay, so that's basically the assumption that we can make. Derive a method to express g of k plus 1, k plus 1 only using j, which is defined like this over here, k, which is the part of the coordinate, okay, because k plus 1 is the new coordinate, and then kk is the coordinate of the last pixel that we have computed a g value for. Constraints, okay, constants, constants. So 1, 2, 10, 3, those are all constants. We only want to use these operators, okay? We only want to use addition or subtraction as operators. So we are trying to avoid the use of multiplication. Squares are implicitly using multiplication, so we want to avoid the use of those as well. Do not use multiplication or division in your method, okay? So that is very explicit. Do not do that. The rationale and derivation of your steps are important. So I don't want people to just give me the final answer. I want people to show me how they get to the final answer. All right, so this is a much more open-ended kind of question compared to the first 3. So I just kind of want to briefly talk about, how to approach a question. Because I think sometimes I got questions like that. It's like, how do I get started? How do I approach it to begin with? So what I'm doing right now is searching for my text box, which is right here. Okay, so that's good. All right, so I'm gonna use my text box here to answer question number 4. All right, so the first thing we want to do is to recall the definitions. Okay, in other words, after you read the question, you want to put all the relevant knowledges into the box first. Okay, you may not know how to link all those concepts in order to solve the problem, but you probably have a good idea of what knowledge you need. Okay, and this is the part where open book and open notes is going to be helpful, because I'm not expecting you guys to remember what is the G function, okay, because it is already defined in my notes, right? And hopefully when you study, you also either highlight that in the notes, digitally or otherwise, or you actually create your own document about all the definitions, because you want it to be, you want to make it easy, okay? I shouldn't say easy, but you want to make it efficient, okay, during the test, to locate your knowledge, to locate definitions. So the first thing we need to do is to say, okay, we know what G is, okay? G of x, y, in general, okay? So this time x and y can be different, but in general, G of x, y is defined to be x plus y times x plus y plus 1, the whole thing divided by 2, and then plus y, okay? So we know this as a definition. Okay, so you can say from the module. Okay, so basically you can just say, okay, where did we come up with this? Well, it's already in the module. So things that are already written in the module, you can kind of just quote it. Okay, you can just say that, okay, this is already in the module. We don't have to explain how we got to that point. Okay, so now you want to look at J. Okay, so J is defined to be G of KK. So using the definition that we have just quoted here, so the quoting of the definition is important because that shows me that you understand what knowledge is needed to answer this question. Now, would that give you full credit for this question? Obviously not, okay? But it would give you some points at least, okay? It would give you at least some points to say that, okay, this particular person at least understand what is needed, what knowledge is needed to answer this question. So the next step is to make use of that particular definition and apply to be specifically here, what would G of KK look like using the G function. So that would not be too complicated, okay, because we got K plus K, and then we got K plus 1, because both x and y are k's, right? So we divide it by 2, and then after the whole thing is done, we add one more k because y is k as well. So it doesn't hurt to simplify this a little bit, okay? So we'll go ahead and expand it, okay? So we got basically 2k times 2k plus 1, the whole thing divided by 2, and then plus k over here. And if you want to make it even more clear, then we got 4k squared, okay, plus 2k, and then put these in parentheses, divided by 2, plus k, and then we can simplify a little bit more. It's 2k squared plus, because of the division by 2, and then we have a plus k, and then we have another plus k. The first plus k is from 2k divided by 2, that's the first k, and then the second k is the k that is at the end of the previous line. So now we look at this and go like, okay, we can simplify this just one more time so that we have 2k squared plus 2k, okay? Is that okay? Does everybody understand how this works out? It's really just an expansion of the G function, and then we just go through some algebra to simplify it, okay? So now, okay, that's good. Thank you, Sandeep, for confirming. So now we look at the G of k plus 1, okay? So we just expand it as normal, okay? And then we try to look at G of k plus 1, and then compare to G of kk, which is already stored in variable j, and see how we can simplify the whole thing so that we do not need multiplication. So now this time we have k plus 1 plus k plus 1. And then on the other side we have k, oops, that's not, oh no, that's correct. So then we have k plus 1 plus k plus 1, because x is k plus 1 and so is y. And then we have one extra plus 1 here, and then the whole thing divided by 2 plus k plus 1 over here. Okay, so it is not going to be surprising that we can probably do some simplification. So we'll go ahead and do this. This is 2k plus 2, and then we have 2k plus 3 over here, divided everything by 2 plus, oops, k plus 1. So now we basically we want to isolate, the terms, the constants go to one place, the coefficient of k goes to one place, and then the coefficient of k squared go to another place, because that is how we can start to quote unquote cancel out things, using the definition of j, so that we only get the difference left. Okay, so we just keep expanding this. So now we have 4k squared. Okay, so let me open paren here, and then we have, let's see, we got 4 and 6, so we have 10k, and then we have 2 times 3, so that's 6 over here. The whole thing divided by 2 plus k plus 1. So we now divide everything in parentheses by 2, and because everything is an even number, so they all kind of worked out kind of somewhat nicely. So we got 5k over here, and then a 3, and then plus another k up here, out here, and then plus another one out here. So now after we combined all of the coefficients, we have 2 times k squared plus 6k plus a 4. Okay. So my math may be wrong, as much as I hate to admit it. My arithmetic, usually doesn't, it's not that good. Okay. But it is in a form that I can now work with. Okay. Okay. All right. Thank you, Sandeep, for confirming that. So now what we want to do is to say, let's look at g of k plus 1. K plus 1. Now the double parentheses are actually needed in this case. Oh, okay. All right, so now we want to look at the difference. In other words, we want to look at this and compare that to j and see what is left. Because whatever is left, I can just add it to j in order to get to g of k plus 1, k plus 1. So now you have the same option, okay? Because, by the time you get the test, you have a document that you can edit. So you can do exactly the same, which is just copy and paste. Now, when you are editing, I would like you guys to edit in place in a document. So don't do it in a separate editor and then paste your answer back into the test. Okay, just work on, use the document that I distribute, that I share with you, and work in that document. Okay, so do not work outside of the document and then just copy and paste later. All right, so getting back to here, this cancels out. Okay, the square term is entirely out, so we only got 4k plus 4 left. The 4k, because we have a 6k over here, but we are also subtracting 2k from it, so we have 4k as a leftover, and then the constant of 4 is all the way here. They look at this and go like, but there's addition. Excuse me. There's multiplication. Not if you look at 4k as that, right? That has no multiplication and there's no division whatsoever. So that means, in order to calculate g of k plus 1, so now I can just say that, this is just plain and simple algebra. So we just say this is the same as j plus, and whatever we have up here, and that is the solution. So the solution is, if I know, okay, if I define the g value of kk as j, and that is tracked in a program, in order to get to the g value of k plus 1, I only need to add k plus k plus k plus k plus 4 to whatever the j is. Now you might say, yeah, but you're adding k 4 times, and that's pretty slow. Well, I mean, there are ways to make this faster, because you can say, you can first calculate, let me see, j, k, l, m, n. Let's use m, okay? So this is outside of the scope of this question, but since I'm mentioning that we want efficiency, so when you write a program and you want the maximum efficiency in this case, then you define a local variable as m, and you define it to be k plus k. So that way, you don't need to add k 4 times, because with m defined as k plus k, then you only need m plus m over here. So you basically save 2 additions because we partially compute k plus k first. Then we can compute m plus m to get to the 4k, and this is how we can minimize the number of actual operations. But the question doesn't ask you to do the absolute optimization, so there's no need to get to this particular solution, which is slightly better compared to the one that I have written over here. But even this one, even though it is not fully optimized, it is still way faster compared to computing g of k plus 1, k plus 1 using this particular form. Because this particular form has a k squared in it, and that is the one part that we need to use multiplication. And doing multiplication in software as a library is very, very slow compared to k plus k plus k plus k. Sandeep is asking, why are we subtracting from k g of k plus 1 k plus 1? Because we I think he's asking, why do we want to get to this result? Is that right, Sandeep? Okay, that's because we just want to get to this point. I mean, however you get to this point is fine. It's just a matter of how do you express g of k plus 1 k plus 1. But since we know what j is, I just decided to subtract j from g of k plus 1 k plus 1 to get to the difference. Okay, and then we just say, okay, now that we know what difference is, then we can compute g of k plus 1 k plus 1 as this particular term here. Okay, all right, cool. Which in the program, this is also outside of the context of this particular program. So that means in the program, okay, in the code, j will be updated basically by this expression, because k plus 1 becomes the next kk. Okay, so in order to get to the next pixel, which is k plus 2, I basically just have to repeat this calculation. This way we can get to the g of k plus 2, the g of k plus 3, and so on. So as long as I'm just, I'm only interested in pixels along that particular diagonal line, I don't need to use multiplication whatsoever. All right, so are there any questions about number 4? I'm just looking at the time just to make sure that I got time for number 5. Okay, so we are all good here. So let's continue on to question number 5. All right, so question number 5 has to do with, okay, so this one is using, has references to functions, it has references to quantifiers, has references to set notations and set operators, and also has references to equivalency of cardinality. So let's go ahead and tackle this question. So the scope of this particular practice exam is identical to what you guys have for this year, which is good, okay, because that means because we are including everything up to and including out of null, but excluding relations. All right, so let me answer the questions one by one. And we'll first start with reading the questions. And please, okay, try to read the questions carefully, because if the question is misunderstood and the answer reflects that, I cannot give people at least not full credit, even if the answer is 100% correct based on the misinterpretation of the question. So you have to read the questions very carefully. If you do not understand what the question is really asking, go ahead and ask me during the test. Okay, that is one reason why I want to schedule time slots, so that I can make sure that I will be present during those time slots on Discord to basically help to clarify the questions. I cannot answer knowledge things. I cannot answer, what technique do we use to answer a particular question, but I can try to clarify what the question is really asking. All right, so this is question number 5. In this question, let us define x to be the set of all non-negative integers powers of 2, such as 1, which is 2 to the power of 0, 2, which is 2 to the power of 1, 4, which is 2 to the power of 2, 16, 32, and so on. Answer the following questions. Evaluate this particular expression. So when I say evaluate and then I give you an expression, that means I'm just looking at whatever is highlighted up here as an expression. It gives you a particular value, so you have to tell me whether it is true or not in this case. Okay, and there's always a little because down here. Okay, so that you have to kind of tell me why you think that is the case. Okay, what makes this particular answer either true or false. So in this case, if I read the question carefully, it is asking, there exists lowercase n as a natural number such that it is not the case that this same n, which is a natural number, is in the set x. Okay, the set x has all the non-negative powers of 2. Okay, so when you look at this set and you look at the natural numbers, the answer is, well, I mean, that's pretty obviously true, right? Because there are some natural numbers that cannot be found in x. We can start with 0. Okay, where is 0 in x? So 0 is not in x, which makes this particular expression true. But since this is an existential quantifier, we only have to find one particular element in n to make whatever is highlighted true for the entire existential quantifier to be true. So the answer is this is true. Okay, so let me go back to my text editor here. Okay, so I would just say 5a is true because 0 is in the set of all natural numbers, but 0 is not in x. Okay, so in the test, if you say, I know all the fancy stuff to type in, the element of and all the fancy, symbols, you can go ahead and use that. Okay, if you are already, well versed in LaTeX, you can definitely use the equation editor. That's fine. But on the other hand, if you say I don't want to waste any time to do all that stuff, this is okay. Okay, as long as you use the word in, which I understand as an element is in a particular set. So that is the implication when people use in, spell out in as an operator. Okay, so that's 5a. Let's work on 5b. 5b is this portion here. So about the same thing, except it's reversed. Okay, so I'm asking, is there an element in x, which is the set of all the non-negative powers of 2, such that that n is not a natural number? Okay, so so I think this time the answer is false. Okay, because every non-negative power of 2 is a natural number. Okay, now that is not even using any set notation. Okay, it simply is, that's, I don't need any further proof, because if I ask for any further proof, I would have to first explain, I think in this case proof by induction would work. Okay, but I haven't explained proof by induction yet. Okay, so that means the answer as I type here, it's fine. Okay, it is okay. You can also use proof by contradiction in this case, but I haven't talked about proof by contradiction also, so there's no need to provide any further proof compared to what I have typed here. All right, so let's move on to 5c. 5c says, evaluate x is a proper subset of n and explain your answer. Okay, so same thing, tell me what the answer is first and then explain it. So the answer is, it is true. Okay, and it's mostly because of the previous two questions. Okay, because the previous two questions really are trying to help you understand why the answer of the third one is true. Okay, so it is true because every element of x is in n, but not every element in n oops, you cannot see that portion. Let me put it over here, is in X. Okay, so let me try to display the question and also the answer at the same time. Okay, I can scroll the question down a little bit. There we go. So this way we can see both. All right, so 5C is true because every element of X is in N. Now, how do we know that? Because I'm just looking at 5A and 5B. So 5B, is answering this part, but not every element in N is in X, and part A is answering that one. So because of the combination of those two, we now know that 5C is true. X is a proper subset of N. So now 5D is asking, can you find a bijective function f so that it takes the set of all the non-negative powers of 2 and map those to natural numbers? Okay, if so, what is the mathematical definition of f? F of x equals 2 blah blah. And what is the mathematical definition of f inverse? Because I want you to find it not just a function, it has to be a bijective function. And if we know that f is a bijective function, it must have an inverse function. So we want to know, how those two are defined. Now, I did not ask about the definition. I specifically asked for a mathematical definition, which means, it has to be something that involves, some kind of mathematical operator, like, sine, cosine, log, exponent of, that sort of stuff. So to answer the question, okay, the first thing is to answer yes or no. Okay, can you or can you not find a bijective function? So now the first part of the answer is yes. Okay, yes to the part of yes, I can find a bijective function. So if you want to be very complete, you can say there is a bijective function. Okay, and now we can define what a bijective function is and what its inverse is. So f of x, which is mapping from non-negative powers of 2 to natural numbers. Okay, so there might be other ways to do it too, but the easiest way to do that is basically the log 2 of x. Is that okay? So any variation of log 2 of x is going to be okay, because you can also say this is the natural log of x divided by the natural log of 2. Okay, that works too, because they boil down to exactly the same thing, but either one works. So if that is the function f, okay, what is the inverse of function f? So f inverse, okay, I'm just going to use the LaTeX notation that I otherwise would need to display f inverse to express that. Okay, so the inverse of that is actually a whole lot easier. It is 2 to the power of x. Okay, because the inverse function is trying to map from natural numbers to all the non-negative powers of 2. So that's actually a little bit easier. Do we have any questions about everything up to this point, up to part 4 of question 5? I'm just looking at the text channel. Okay, no direct message, no text whatsoever. So I am going to assume everything is still good. Okay, I'm just double checking to make sure my Discord has not crashed, because sometimes it happens and I just assume that nobody has any questions, but I know now that everything is still going. All right, cool. So now we can move on to the next part of question number 5. Let me scroll that into view first. All right, so the last part, okay, I'm just gonna cover up the other parts that we have already answered. So the last part asks this question. Okay, it is asking evaluate the cardinality of x equals to the cardinality of n and explain your answer. Okay, so the first part, which is to answer this question here, the cardinality of x equals to the cardinality of n is what, right? So that answer is not aleph no. It is asking whether they are the same or not, right? So the answer is true. let me just kind of pause here because I just want to see whether people have questions about this. We don't have any questions. All right. Cool. Okay, so the first part is true. Now we have to explain why that is the case. Oh, okay, Omar is asking a question. Okay, we are using the, yes, so equal sign in this context is equality check. It is not an assignment. That is correct. So in C and C++, you can chain assignment operators, but you cannot chain, well, I shouldn't say that. But you cannot chain equality or equivalency not the same way. Okay, so so the first part, and this is why I use parentheses, because the parentheses basically ask that to evaluate this first, right? So if equality, assignment doesn't work in this case because you cannot change the cardinality of another set. The cardinality of a set is a function, okay? It is a way to calculate something. So you cannot just change the cardinality of a set by the cardinality of another set. So the only correct interpretation of this single equal here is a comparison. So that means you first have to perform this comparison, but comparison only gives you a Boolean value. It's either true, yes, those two things are the same, or no, or false, those two things are not the same. So that means by the time we get to this particular equality, whatever is on the left-hand side is going to be a Boolean value. So whatever is on the right-hand side has to be a Boolean value as well. So that's partially why the answer of the first part is true. Okay. Now we have to explain why that is the case. So if you go back to Aleph null, the module that talks about Aleph null, the equivalency of cardinality is established by whether a bijective function exists between the two sets. Okay, so that's all you need to do. Okay, so you just have to say, because there exists a bijective function that maps x to n. Okay, I can't really type the fancy n here, but that n is supposed to be the set of natural numbers, and the x is the set of all non-negative powers of 2. So this is already sufficient. Okay, the keyword that needs to be here is bijective. Now you can use bijective function, or you can say bijection. Okay, either one is okay, but bijective itself is not exactly a function. So if you use the word bijective, you have to use function after that. But this is already enough to answer the question, because that is basically the knowledge that I want to test. Okay, do you understand what establishes the equivalency of cardinality between two sets, particularly when one of them is the set of all natural numbers? So this is definitely a trickier-ish question, because the first part of the question, let me just kind of unhide that portion. Okay, the tricky part has to do with this. Okay, because we have first established that x is in fact a proper subset of n. So to most people, this basically is saying, oh, okay, so that means the cardinality of x is certainly less than the cardinality of n. But that really is not the case, because they both have an infinite number of elements. So when you're talking about a set with an infinite number of elements, then what we intuitively understand that, oh, because this is a proper subset of the other one, the cardinality has to be less than the other one. That concept does not apply anymore, because infinity is not a number that you can compare to another infinity. Okay, it is undefined. You cannot do that. So as a result, to evaluate whether the cardinality of two sets are the same or not, now we have to resort to the use of a bijective function. So if we can find a bijective function, then we can say, yep, because for one of these, there's one of those. For one of these, there's one of those. But we can turn it around and say, but guess what? For one of this, there's also one of this. For one of this, there's also one of those. So now we can establish the equivalency of cardinality. So this question is not tricky from the perspective of what it's asking, in terms of what you can use from the definition of the operators and the definition of equivalency of cardinality. It is not tricky, but it is somewhat mentally tricky when people want to use the intuitive understanding of subset of and the intuitive understanding of cardinality instead of using the mathematical definition that I have put into the modules. So that's it. I mean, those are the 5 questions in this actual test of spring 2020. All right, so I am going to open up, quote unquote, the floor to see if there are any questions from you guys. And I know some of you are watching from YouTube, so that might take a little bit longer before I get everybody's feedback. I'm looking at YouTube right now. We got 3 people watching on YouTube. I can show you how I know that too. Let me move that window into view. I think most of you know this already, but it's just kind of interesting to see it. So this is what I see, from the YouTube side, and the YouTube side has a graph to basically show me, viewership, of this particular video on YouTube side. So that's kind of interesting. All right, so I got 2 feedback. Aaron typed, nope, but I'm sure when I'm cramming the notes on Sunday, I assume, I will. And Omar said, you mentioned we can also write our test on paper. So should we submit a PDF to Canvas? The answer is no. You still use the shared document because you can copy and paste an image into the Google Doc, and that's how I want to collect all the answers. Roll. Okay, yeah. Okay, let's talk about roll. So I will work on it now. All right, so let me move this here. And I have no idea why I was looking at this page. I cannot remember, obviously, at one point in time. Oh, right. This is a Markdown, and I was looking up from the other class how to make a table in Markdown. So that's why I was looking this up. So let me make a role-taking quiz. We still got time, right? Yep, we still got a little bit of time. So for those of you who want to think of a question to ask, we still got a few minutes. So please go ahead and use that time. I think this is the wrong class. Yep, this is my evening class. And let's go back to this class here. Since I just saw the term Zoom meetings, or the phrase Zoom meetings, so what do you guys feel about Zoom compared to Discord? Oh, the question was the comparison between Zoom, which is what Confer Zoom really is, compared to Discord. Okay, we can go back and talk about 5D a little bit more. How did I get the function? That is that's just based on what I know about log and exponent. So I can't really okay, I can show you that in just a little bit. Let me finish the question first. All right, so let's add a new question. and not make it multiple choice. So we'll make it fill in the blank. Okay, what is tax word for road taking on 9/22? And let's make it Discord with the uppercase D. Okay. It's just really whatever is on my mind right at that moment. All right, and we'll give it, okay, so turn that off and give it a due date of 1 day. So that will be September 23rd at 10:30 a.m. September 23rd, 10:30 a.m. And we are done with this. Okay. So go ahead and take row first, okay? Because it's fresh. It is just Discord with the uppercase D. And now I'm going back to Discord and read all the questions or answers in this case. Yalis talks about meeting. I'm not sure what that is referring to. I guess there's an app called Meeting. Zoom has a hands up feature, but it seldom gets used. Okay, whoever is coordinating has to tell people to make use of that feature. Some people do and some people don't. Zoom has a local recording session record feature. Yes, that is the case. But then whoever is doing the recording has to upload it, so it doesn't stream directly to the internet. And then Omar says, I don't think there's anything Zoom does that cannot be done with Discord. The one thing about Zoom is Zoom basically can scale up. If I turn on one-way streaming, Zoom can handle more than 25 people watching at the same time. Whereas in Discord, if people want to be able to do the interaction with the voice, we can only have up to 25 people. But then, if I want this to be just one way, YouTube is the other way to do it. I don't know about the lag time between Zoom and YouTube, which one, how they compare. Okay. All right. So, okay, so I think most people do. I think no one at this point likes Zoom better. Okay, so Zoom does have a better lag time when it's blasting to a huge number of people. Okay, Iraj started using Zoom instead of YouTube because latency was better. Yeah, I think the Discord live communication is the best. Okay, especially if you guys want to also use your voice to ask questions. I think Discord is actually pretty good for that. But I kind of like it that I can easily make one channel a day, and then it doesn't automatically get rid of all the text content, and we can copy and paste screenshots and whatnot too. I think that is a huge plus when it comes to this. Twitch, yeah, well, considering what Twitch is intended for, Twitch has to have a much better lag time. All right. So let me go back to answer Sandeep's question. Can I explain 5D a little bit more? Okay. So let me go back. Oh yeah, if you want to chat on the side and not as a part of the class, Discord gives you DM, and because everything is pretty much in the same view, you can kind of go between your direct message and go back to the class pretty easily, or have one device to stay on one channel and the other device to stay on another channel. So you get to you can distract yourself really a lot using Discord. And that's not even considering all the other channels all the other servers that you have joined already. Yeah, that would be nice. Aaron, you can write to Discord and suggest that as a feature. Discord is hiring big time, by the way. They're hiring a lot of people, both in terms of administration, management, and also development. So, okay. Then you need to convince the rest of the class to do it too. So we'll blast them with that request. Okay, so getting back to Sandeep's question about 5D, okay, which is how do I find the function f? So this is one way to do it, because I just thought about this a little bit of how to answer this question. So maybe one way to answer this question, 5D, is first to find out what the mapping is going to look like. Okay, so in other words, instead of using a mathematical definition, so we can say f equals 2. Okay, so we are going to map 1 to 0. We're going to map 2 to 1. We're going to map 4 to 2. We're going to map 8 to 3, and so on. So what this is doing is giving you an idea of what it is actually doing. Okay, from a set of two tuples perspective. So now we look at this and go like, okay, how do I turn a 1 to a 0? How do I turn a 2 to a 1? How do I turn a 4 to 2? How do I turn an 8 to a 3? So that is why I just come up with the answer of, oh, okay, we're just taking the log 2 of x. In other words, the log 2 of x is potentially a irrational number, where if you take 2 to the power of that, you get x back. Okay, so yeah, so that's kind of the thought process that might be helpful, is to find out specific examples, okay, using concrete values. Okay, what from x is mapped to what in n, what in x maps to what in n, and then see whether you can see that a pattern in this whole thing, and then associate that pattern with a math function that I kind of expect people in this class to be familiar with. Yep, yep, exactly. So this part is not needed as part of the answer. So this part here is just me showing one way to approach the problem to get to this portion of the answer. All right. Yep. Okay. So I'm getting back to Aaron's comment about popping out chats. Yes, I do agree that that would be very helpful. The only alternative to do that, and some of you will like that answer, is to run multiple virtual machines, or if you are using Linux, you can also use Wine, because I think you can install multiple instances of Wine in different, what they call, there's a name for that, I cannot remember, but they can all be in different subfolders, and yes, more layers, more more everything, complicated, and then we'll get a solution, right? Make it more complicated. But Wine is relatively thin, as an emulation layer, so you can basically just run multiple versions of Wine, and then each one has its own Discord. Then they are separate from each other. They won't conflict with each other. They won't even know of the existence of each other. Except at the Discord server level. The Discord server would go like, hey, this is crazy. You got 5 different instances making connections to the same server, but it's okay. I mean, Discord handles that really well. I mean, because I have done it. Okay. Oh yeah. Technically, you can have 3 Discord installed in Windows. Actually, if you want a really convoluted solution to this, you can run multiple, and you can run multiple Android emulators in Windows, and then in each one install Discord as a client. So you have basically emulations upon emulations upon emulations in order to get to use Discord, one on each server. But they'll all be in a mobile platform. No. This is actually an IQ 30 type of answer to basically make it as convoluted as possible. But I think Docker may work too. So that I have not looked into. So maybe Docker as a very thin layer, not even an emulator, may be able to do it. So you might want to look into Docker as a solution too. Yes, it depends on which Android emulator. If you get an Android emulator that is based on the x86 architecture, those are actually pretty efficient. On the other hand, if you get an ARM-based, Android emulator, yes, that will basically suck the life out of your PC instantly. The trusted ones. Yeah, if you you can install. Okay, I know this is way out of the scope of this class, and it is also getting even more convoluted. You can get Android Studio, which includes the manager for Android virtual devices. But that one is kind of nice because it gives you a lot of options, of what firmware to use and what device it is emulating. Alrighty. Yeah, it is huge by itself. Okay, the ID itself is huge too. All right, so we are out of time. We have been out of time for about 4 minutes. So if there are no extra questions, I think I can stop the screen share and the streaming, and Aaron and I can continue the exchange of using Android and other ways to make more windows of Discord. So does anyone else have any questions? I just want to make sure that I get all the questions. Okay, nothing. All right. So what I'll do is I'm just gonna discontinue the screen share and also the streaming, but I'll stay online for another hour or so as my office hour, and then I have another meeting starting at 1:15. So I just went from one meeting overlapping with this class and then onto another meeting. Yep. All right.